What's up guys, and welcome to this tutorial. We are going over question 6, which has to do with gravitational fields of the 2018 supplementary exam. Oh no, actually it's a 2018 final exam. Okay, cool stuff. Let's read the question. Okay, so an astronaut on a planet wants to determine the acceleration due to gravity. The astronaut has a number of different masses available and determines the weight of each mass. Okay, so the first question says 6.1, it's a bit of a theory definition kind of question. It says distinguish between mass and weight. Okay, so basically it's asking for what is the difference between mass and weight. Okay, so we know that weight is the gravitational force that the Earth exerts on an object. Okay, and we know that weight is a vector as well, whereas mass is the quantity of matter in a body. Okay, and it is a scalar. Okay, we also know that weight is a force in newtons, whereas mass is in kilograms. Okay, cool stuff, and that should be enough to get us 4 marks. Question 6.2. Okay, so plot a graph of weight versus mass. Okay, on axes which are provided. Okay, it even tells you what axes to put. Okay, so so let me just draw it. Mine's obviously not going to be as accurate, but okay. Anyway, so it says, okay, so first always remember that you need to label your 0 points. Okay, so on the x-axis we have mass in kilograms. On the y-axis we have weight in newtons, and we're going to say this is a graph to show weight versus mass. Okay, and that's going to be our heading. Okay, so I can also already see running out of a bit of space, so let's try and move that down. Okay, cool stuff. Okay, cool stuff. Okay, now I'm just going to plot some points. Okay, so let's see. Our mass goes to 0.7, so I'm going to go up in 0.1s. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7, whereas our weight goes to 2.7. Let's go up in 0.5s. Okay, so 0.5, 1.0, 1.5, 2.0, 2.5, and let's end off on 3.0. Okay, cool stuff. So the first one is 0.1 and 0.3. Let's say that's somewhere there. Okay, let's mark it with crosses. 0.2 and 0.7. Let's say that's 5. 7.5 is roughly there. 0.3 and 1.05. That's just going to be above 0.5. So we're going to skip 0.4, and we have 1.9. So just under 2-ish, and then 0.6 and 2.18, so 2, let's say that's 1, so nearly 2.2, somewhere there. And lastly we have 0.7 and 2.7, so 2.75 is the middle, so just under the middle. Okay, something like that. And then we can draw a nice straight line through all the points. Mine's obviously not going to be so straight, but something like that. Okay, and that's our graph, and we should get 6 marks for that. Okay, then it says calculate the gradient of the graph. Show the values you used on your graph and indicate. Okay, so let's see what values. Okay, so for what is it, 6.3, we want the gradient is equal to our change in y over change in x. Okay, so let's see. Okay, whatever values we pick, let's pick the point. Let's say it goes straight through that point, so that, let's say, is point 1, and let's say it goes straight through the last point. Maybe it does, maybe it doesn't, so that's point 2. But you should ideally look for a nice point, let's say 0.4, and we go read it off the graph. But because my graph isn't too great, I'm just going to pick values that we know. So let's say, okay, so point 2 is going to be, change in y is, I'm going to use 2.7 minus 0.3 over 0.7 minus 0.1. Okay, so those are the 4 points I used. So we have 2.7 minus 0.3 over 0.7 minus 0.1. Okay, and we get a gradient of approximately equal to, let's just say 3,9. Yeah, let's say 3,96. Okay. Okay, now we need to figure out what the units are. So it's going to be Newton per kilogram. Okay, so according, we should actually get a value, any value between 3,56 to 3,96 should be fine, or is acceptable. Okay, so you have a bit of a range there. Yeah, okay, and the way I got the units is we take the units of the y divided by the units of the x. Okay, but we can also simplify these units. Let's see, are we going to simplify it? Yeah, let's go for it. Okay, so Newton is a force, a force which is a mass, so it's a kilograms times acceleration, so meters per second squared over a kilogram. Okay, so that these two things are equal. These kilograms cancel each other, so we're left with a meter per second squared. So our gradient is also equal to, roughly equal to, let's say 3,96 meters per second squared. Okay, either of these units is actually fine. It doesn't really make too much of a difference. Okay, so include appropriate units in your answer. Okay, so we've done that, so 6.3 is done. Okay, so the next question is 6.4. Okay, so 6.4 says, hence determine the acceleration due to gravity. Okay, so the acceleration due to gravity is, we can say g. Okay, so we already know what the units here is, meters per second squared. Okay, so our units for gravity is in meters per second squared. So what our gradient is equal to, our acceleration due to gravity is equal to g, is equal to 3,96 meters per second squared. Okay, so we get 3 marks for identifying that the gradient actually gives us the gravitational force, or otherwise we could have said that weight is equal to mass times gravity, and g is our gradient, and so we calculated that already. Okay, cool stuff. Question 6.5. Okay, so we've been given the values of g, and it says, okay, so we've got Venus, Mars, Jupiter, and Pluto, and we've been given g, the gravitational forces of them, and it says which planet is the astronaut on. Okay, we came out with 3,96, so the closest would be Mars. Okay, and 6.6, it says the radius of Pluto is 1.1 times 10 to the 6 meters. Determine the mass of Pluto. Okay, so the governing equation is going to be g is equal to the gravitational constant times the mass of the planet times the radius of the planet squared. Okay, so we're concerned with Pluto, so we know what g is. It's 0.58. is equal to, the gravitational constant is 6,7 times 10 to the minus 11 times the mass, which is the unknown, over the radius in brackets, I'm going to put it 1,19 times 10 to the 6, and all of that is squared. Okay, the only unknown here is m, so we can solve for m, and the mass comes out as being 1,23 times 10 to the 22 kilograms. And that is the final answer. Okay, cool stuff. Yeah, and that's that question, 23 marks, all done. And in the next video, we will be doing question 7. Okay, thanks for watching, guys. I hope you guys found it useful.